All right, we got a little bit more of an intense example here. So we got angles and tensions. All right, so let's give it a shot. So it says a 4-kilogram block in the figure is attached to a vertical rod by means of 2 strings. When the system rotates about the axis of the rod, the strings are extended as shown in the figure. The tension in the upper string is 80 newtons. What is the tension in the lower cord? Start with a free body diagram, of course, and then what is the speed of the block? All right, so they're telling me that I got this is 80 newtons, all right, and it's spinning around here, and I want to find what is this tension and how fast is it moving, what's the speed. So I'm going to be ending up trying to find this V term down here. So first thing I need to do, draw a free body diagram. Now, I need to generate my equations. I also need to identify the direction of the centripetal acceleration. It always points toward that axis of rotation, and that is defined as my positive direction. All right, so in order to sum up the force in the y direction, my object is not accelerating up or down, so I do need to resolve T1 into components, and I need to resolve T2 into components. So I have in here, I have my T2 cosine of theta. This angle, I'm going to go ahead and find that angle because they told me this distance was 2 meters. So that means this is 1 meter, and they tell me the string length is 1.25 meters. So I kind of know something about this triangle. I can use my inverse sine to find that angle, and it comes out to 53 degrees. This side here is T2 sine of theta. Up here I have kind of the same setup. My goodness, there's getting pretty busy here. T1 cosine theta, T1 sine theta. All right, so let's go ahead and generate our equations from that. And maybe I'll redraw that. That's kind of getting messy there. So I have T1 sine theta. Oh, there's only one force up. And then I have T2 sine theta. And I have mg. And then I have 2 forces this way. I have T1 cosine theta, T2 cosine theta. Okay, so that's my free body diagram redrawn. That'll help me kind of identify, okay, what's in my y direction, what's parallel to my radius direction. So in my y direction, I see I have T1 sine theta minus T2 sine theta minus mg equals 0. So I have 2 unknowns here. Actually, I only have 1 because I know theta. It's 53 degrees. So I'm only missing T2. So we can go ahead and solve this. So now I have T1 sine theta minus mg, all divided by the sine of theta equals T2. Go ahead, plug in my numbers. So I have 80 times the sine of 53. Make sure you store that angle on your calculator. It's not exactly 53 degrees. Minus 4 times 9.8, they told me the mass was 4, divided by the sine of 53 equals T2. These sine of 53s do not cancel. If you want to do something like that, you do have to distribute that sine 53 to both of the top terms. T2, we should get a value less than 80 because remember the 80 is not only making it go in a circle just like T2 is, but 80 is also supporting that mg. And when we type that into our calculator, we get 31 newtons. Now to find the speed at which it rotates, I'm going to have to go ahead and generate my other equation over here. So I look in my parallel to the radius direction. I have T1 cosine theta plus T2 cosine theta equals MAC. Now inside that AC is that speed we are looking for, so we are going to go ahead and substitute in V squared over R there. I'm going to factor out a cosine theta here as well, so T1 plus T2 times the cosine of theta equals MV squared over R. Now it's just a matter of me isolating that V and getting a number there. So I'm going to multiply by R, divide by M, and take the square root. So I have R times T1 plus T2 times the cosine of theta, all divided by M. Take the square root will give me my speed. If I go ahead and plug in my numbers here, so R, okay, R is going to be this distance right in here. All right, let's see, we got one more color left. And so if I think about my triangle here, this is actually a 3, 4, 5 triangle. And so this side here is going to be 0.75. So like 3/4, 4/4, 5/4. That's my 3, 4, 5 triangle I have there. All right, so now I just need to plug in those values. So I got my 0.75 times 80 plus 31 times the cosine of 53, all divided by 4. Make sure that cosine of 53, make sure you store that angle. That will tell me the speed at which that block is moving around there, and that speed comes out to be 3.5 meters per second. So some of these problems can get kind of intense. Just remember, it's all about following those steps, drawing that free body diagram, redrawing it if you have to kind of see what am I doing, generating those equations, doing the algebra, substituting in where need be, and solving.